So now I can finally talk to you about what is a coordinate proof. So these are proofs that are done on a coordinate plane. The difference being we typically don't know how big the shapes are. Um, this is not going to look like a traditional proof where we do two column or paragraph or flow. A lot of this is us showing our work because we're basically going to boil down to doing three different things. We're going to be using slope formula, we're going to be using distance formula, we're going to be using midpoint formula. And then a little bit of explanation for what our work is telling us. So for example, if I want to show segments are parallel or perpendicular, I will find the slopes of the segments, and then from that, make a short explanation of, hey, from this, because the slopes are the same, these segments are parallel. Or because the slopes are opposite reciprocals, these segments are perpendicular. Um, Distance formula. When we actually were doing side, side, side for congruent triangles on the coordinate plane, those were actually a type of coordinate proof. So if I want to show that segments are congruent, I'll find their lengths by using the distance formula, and then I make a short statement of, oh, since the lengths are the same, these two segments are congruent. And then occasionally we're going to need midpoints. It's usually done in combination with either then doing the distance formula or then finding slopes. It's usually not a midpoint by itself, but we do occasionally need to use the midpoint formulas to find the coordinates of midpoints. So some examples. So let's say that I wanted to write a coordinate proof to show that this drafter's triangle, it is actually called a triangle because it is a triangle, is shaped like a right triangle. So we're told that one length has a side of 10 inches and the length of the other side is 5.75 inches. It has already been placed onto a coordinate plane for us with coordinates labeled, including that D, whoops, helps if I don't use the highlighter to write, is at 0, 0. So I want to prove this is a right triangle. To prove it is a right triangle, I need to prove it has a right angle. And if it has a right angle, that means two of the sides are perpendicular. So what I'm going to do is I'm going to look at each side. So I'm going to look at DE, DF, and EF. And because I want to decide if two segments are perpendicular, I'm going to find their slopes. So the slope of DE would be 10 minus 0 over 0 minus 0, which is 10 over 0, which is undefined because we're not allowed to divide by 0. But that makes sense because it's a vertical line. Vertical lines have an undefined slope because there's no change in x. If I look for the slope of DF, that's going to be 0 minus 0 over 5.75 minus 0, which is 0 over 5.75, which is 0. And then my slope of EF would be 10 minus 0 over 0 minus 5.75, which is 10 over 5.75. And what I can tell from this is that from right here, DE, segment DE, is perpendicular to segment DF. So that means I have a right angle, and triangle DEF is a right triangle. And all of this is my coordinate proof because I found the slopes, showed that I have two segments that are perpendicular, which makes a right angle. So my triangle is a right triangle. Please notice it looks very, very different from what we're used to doing with proofs. Most of this proof is just showing my work using distance formula, slope, or midpoint formula with a short explanation of what that work means. So if I now go to another example, I want to write a coordinate proof that shows that triangle ABX is congruent to triangle CDX. I have several options in this because I can do side, side, side and use distance formula to show all three pairs of sides are congruent. But I could also take advantage of vertical angles and do side angle side. I'm going to do side angle side. So I know that angle BXA is congruent to angle CXD by the vertical angles theorem. And I'm choosing to do this because it means I have to do less distance formula, because I only now need to show two pairs of sides are congruent. So then, according to my congruence statement that I'm trying to prove, BX should be congruent to DX. So I'm now going to find the length of BX and the length of DX. So this is where distance formula comes in for BX. 0 plus x is just x minus a plus x over 2 squared plus b minus b over 2 squared. Well, x over 2 is 2x over 2 to get a common denominator, 2x minus a minus x. So I have x minus a over 2 all squared plus b over 2 squared. And I'll wait to simplify that a little bit until I see what I get with dx here. So with dx, I got a minus a plus x over 2 all squared plus b over 2 minus, I'm sorry, plus 0 minus b over 2 squared. All right, I am going to have to do some simplifying with these. So this is going to give me a minus x over 2 squared plus negative b over 2 squared. So for this, if I square everything out, I've got x squared minus 2ax plus a squared all over 4 plus b squared over 4. If I multiply everything out here, I'm going to have a squared minus 2ax plus x squared all over 4 plus b squared over 4. And all that's in the radical. These are actually the same, because remember, the order of addition doesn't matter. So from this, I can say that segment BX is congruent to segment DX. If I then go ahead and repeat this with, so I've shown this is congruent, whoops, my color's consistent. I've shown this is congruent to this. I now need to look at AX and CX. So AX is going to be a plus x over 2 minus 0 squared plus b over 2 minus 0 squared, which is going to be a squared plus 2ax plus x squared over 4 plus b squared over 4. And then get a little separation here. If I look at cx, that's going to be a plus x minus a plus x over 2 all squared plus b minus b over 2 squared, which is going to give me a squared plus 2ax plus x squared over 4 plus b squared over 4. And since these are the same, this tells me that segment AX is congruent to segment CX. And so all of this together means that triangle ABX is congruent to triangle CDX by side angle side. So again, all of this is my coordinate proof. I'm showing my work and giving short explanations. So the orange and the green is my work. The purple are my short explanations of what the work is telling me.